The quantum enigma, a peek into the subatomic world. Imagine a world where the very act of observation alters reality, a place where simply looking at something can change its very nature. This isn't science fiction. It's the baffling realm of quantum physics, a world operating under rules vastly different from our everyday experiences. Here, the laws of classical physics, which govern our macroscopic world, no longer apply. In this subatomic theatre, particles like electrons and photons exhibit strange behaviors, defying the predictable laws of classical physics. They can exist in multiple states at once, a phenomenon known as superposition. Here, things aren't always as they seem. Particles can be in two places at the same time, or even entangled, meaning the state of one particle can instantly influence another, no matter the distance. One of the most perplexing phenomena in this quantum realm is the observer effect. This effect suggests that the mere act of observing a quantum system can influence its behavior. It suggests that the act of observing a quantum system influences its behavior. When we measure or observe these particles, we force them into a definite state, collapsing their wave function. Imagine a game where the players change their strategies depending on whether they are being watched or not. This is akin to how particles behave under observation. That's the observer effect in a nutshell. It's a concept that has puzzled scientists and philosophers alike for decades. This concept challenges our intuitive understanding of the world. It forces us to rethink the nature of reality itself. It suggests that reality, at its most fundamental level, might not be fixed but fluid, influenced by the act of observation itself. This fluidity of reality opens up a world of possibilities, making the quantum realm one of the most fascinating and mysterious areas of modern science. The double-slit experiment, waves or particles. The strangeness of the quantum world is best illustrated by the infamous double-slit experiment. This experiment has puzzled scientists and philosophers alike for decades, challenging our understanding of reality. Imagine shining a beam of light through two narrow slits. This simple setup has profound implications for our understanding of the universe. Common sense dictates that the light should pass through the slits and create two distinct bands on a screen behind. This is what classical physics would predict. And indeed, this is what happens when we're not looking. The light behaves just as we would expect, forming two clear bands. But here's where things get weird. The moment we decide to observe the light more closely, everything changes. When we try to observe which slit each photon of light passes through, the pattern on the screen changes dramatically. Instead of behaving like particles, the photons start to act like waves. Instead of two bands, we get an interference pattern, as if the photons were waves interfering with each other. This wave-like behavior is completely unexpected. The photons seem to know when they are being watched and adjust their behavior accordingly. It's as if the act of observation itself influences their state. This is the heart of the observer effect, demonstrating that the act of observation itself can alter the state of a quantum system. This phenomenon challenges our very understanding of reality and suggests that at a quantum level, the universe is far stranger than we can imagine. Reality is rendered. Does the universe behave like a computer simulation? Now, let's take a leap and connect the observer effect to a mind-boggling possibility. What if our universe is a giant, sophisticated simulation? Imagine a reality where every atom, every particle and every interaction is governed by a complex code, much like the ones that run our most advanced computer programs. Think of a video game. The game world exists in its entirety, but only the areas visible to the player are rendered in detail. This selective rendering saves computational power and resources. Could our universe operate similarly? Could it be that the vast cosmos around us is only rendered in full detail when we observe it? The observer effect, with its suggestion that reality solidifies upon observation, lends itself intriguingly to this simulation hypothesis. When we look at particles, they behave differently, almost as if they know they're being watched. Could our conscious act of observation be the trigger that renders the universe around us, collapsing a sea of quantum possibilities into the concrete reality we experience? This idea suggests that our awareness plays a crucial role in shaping the world. This idea, while speculative, is a fascinating exploration of the boundaries between physics and philosophy, blurring the lines between observer and the observed. It challenges us to rethink our understanding of reality and our place within it, merging the realms of science fiction and scientific inquiry. Section 4. Consciousness and quantum quirkiness. Are we the ultimate observers? The simulation hypothesis raises another intriguing question. What constitutes an observer in the quantum sense? Does it require a conscious mind, or can any interaction with the environment be considered an observation? Some physicists believe that consciousness might play a crucial role in the observer effect. They argue that consciousness is what collapses the wave function, forcing the universe to choose a specific outcome from a multitude of possibilities. This idea, while controversial, places consciousness at the center of reality, suggesting that we are not just passive observers, but active participants in shaping the universe around us. Section 5. The Matrix Within. Unpacking the implications. The implications of the observer effect, particularly in the context of the simulation hypothesis, are profound. If our reality is shaped by observation and consciousness plays a role in this process, then our understanding of free will, determinism, and the nature of reality itself is up for debate. Are we truly the masters of our fate? Or are we merely characters in a grand cosmic play, our choices predetermined by the rules of the simulation? The answers to these questions remain elusive, pushing us to confront the very essence of our existence. The observer effect challenges us to rethink our place in the cosmos, suggesting that we are not just observers of the universe, but active participants in its unfolding story. Section 6. A Dance of Possibilities. Navigating the quantum landscape. Despite its mind-bending implications, the observer effect doesn't imply that the universe is random or chaotic. Instead, it suggests a universe governed by probabilities, where multiple possibilities coexist until an observation is made. Imagine a vast ocean of potential realities, each wave representing a different outcome. The act of observation is like a gust of wind, collapsing these waves into a single, defined state. This probabilistic nature of reality opens up fascinating avenues for exploration, suggesting that the universe is not a static entity but a dynamic, ever-evolving tapestry of possibilities. Section 7. A Universe of Wonder, the unending quest for understanding. The observer effect, with its profound implications and philosophical enigmas, reminds us of the vastness of the unknown. It highlights the limitations of our current understanding of the universe and encourages us to embrace the mystery. As we delve deeper into the quantum realm, we are confronted with more questions than answers. Yet, this pursuit of knowledge, this unraveling of the universe's secrets, is what makes the journey so enthralling. The universe, with its quantum quirks and cosmic wonders, continues to beckon us to explore, to question and to marvel at its infinite mysteries.